Here we are back in the solar room again, and we have a live split panel. So what I got here is, this is coming, going to the inverter. This is somewhat temped in, somewhat permanent. This comes from the generator. We have a 100 amp breaker for now, because that's my last 2-pole breaker. And number 6 wire coming down through this gutter along the back where all the sticky backs are. And that comes over here through the wall. Now I have a piece of 2-inch PVC, and I use PVC because it was difficult to go through the wall. And if I come around here on the other side, you'll see this is going to be the power inlet. So over here on the other side of the container, near all this junk, in other words PVC pipe and conduit, I have a 6 by 6 by 12 Neiman 3-yard gutter. Strain relief comes down and goes along the ground right over here into this adapter cord, and this adapter cord comes to our Wacker & Newson 14 kilowatt generator. I got this used from Blue Line Rental Company, and it's diesel. This is in the engine compartment. So I got this maybe a month ago now, and you can see the engine information here. And we have these new diesel tanks, 96 gallons a piece, so about 300 gallons of diesel. Here's the nameplate on these tanks. And here's the generator. You can see the control panel. You may have seen a little tiny video of the voltage bouncing around on this, but that's been corrected. Here's the true nameplate of the generator. So it's 14 kilowatt, and all that it needed was a new voltage regulator. We picked this up for $5,500, and they said they'd cover anything wrong with it. The rental company said they'd cover anything wrong with it within 30 days. And when I took it home and hooked it up, I realized the voltage was all over the place. So they gave us installed a new voltage regulator. Here's the diagram of that voltage regulator adjustments. I tried readjusting it multiple times and had no luck. Here's the diagram of the actual generator. So this is single phase only, but we do have our hardwire connections too if we want. And 50 amp 12240, 30 amp 12240, and a 1515 and a 15 amp receptacle. Here's all the breakers for those. Main breaker, and to start it, you just hold it, first it clicks to the run position, you hold it to the glow plug position, and then when the light goes out, crank it over to start. And as you can see, it comes to life. So yeah, it has a shocker pass. I forget what that means, but that's a positive air shutoff system. So essentially what that means is it has a flapper in the intake. So if you hit either this emergency stop or this shutdown switch, it'll actually choke out the intake. So if you have it, for example, on diesels, it's called a runaway diesel. That system you can use to shut it down. Let's not trip on that cord. It's got the battery in the back, and engine, and it tows with a 2-inch ball. So that's our generator. For those of you wondering, we used to run 3 Honda generators, all synced together, but that got really fuel inefficient. This thing's rated at full load 21 gallons in 16 hours, but the other day I ran it maybe 6 or 7 hours, and it only went through about 2 gallons of fuel at a light load running the battery charger. So really pleased with this purchase. It'll make great use here off the grid. So this is now mine. It's no longer a rental. So that's the generator. Back at it some more here in the electrical room. Currently generator is running, inverter's charging the batteries, but we have the gutter going across the ceiling in place with our gutter dynies. Haven't got the light fixed yet, but it's a work in progress. So if you look, I don't know if I showed this previously, we have our, what was that, 1.5 inch? Yeah, 1.5 inch, 90 going up. I still need a 2-inch conduit running down here. But if you look up here, I'm all sticky back on the generator power. The other one's not yet because it's still a work in progress. But I'm all bonded together on my grounds. I got another lug here grounding, and that all comes down. We have another dual rated terminal for grounding. This is my generator power inlet. We're bonded to our 3.5 inch chase nipple, and we come down in here all nice and neat with sticky backs all over, bonded to all of our 2-inch chase nipples into the generator panel, and we are made up in the generator panel. I still need to fill all these open spaces with panel blanks, but here we have 100 amp generator input because I don't have a smaller breaker available, but I'm going to change that out to 60 amp. And then 50 amps going to the inverter charger. And what the plan is to have another control cabinet here with a transfer switch, so generator power and inverter power transfer back and forth to feed this panel. So currently the inverter feeds this panel directly, but eventually when I get the right breakers and stuff, this will be fed from the inverter. This and this will feed a transfer switch, so if this is electrified, then it transfers to use the generator power to feed this panel. If this power goes out, then it'll switch over and use this half of the panel to feed this panel. So I don't know if that made sense in the split bus, when I was saying split bus, what that meant, but that's what that is. So, and then anything I want only on the generator can be in this half, anything only on the inverter in this half, and so on and so forth. So I really have a lot of choices on how I can split that up. But yeah, we have our gutter in, and man, that was a nightmare fighting in. I had to disconnect my bus bar, put a piece of cardboard and a plastic clamp on the positive because I did not want that gutter to hit that bar, because that would have been a problem. So we are currently dead on that half of the rack. I'm not so worried about the negative because negative is bonded to earth ground. So if something's grounded and it touches the negative, we have no problem whatsoever. So yeah, I need to get some more conduit in. This half is still pretty sad, but once I get that 2-inch conduit in, I can feed my 4/0 aluminum down and over for these charge controllers. One thing I also picked up, well, actually ordered on Amazon, were these 40 and 80 amp circuit breakers. This is the 80 amp breaker, the information on that. And this is the 40 amp. And I think there's more on the other side. Yep, here's the other side. So I'm going to use those on these charge controllers if it'll focus. Yep. On these charge controllers, the 40 amps on the solar side, the 80 amps on the output to the batteries, because these are 80 amp charge controllers. Still need an enclosure for them, but that's the game plan at least. So that's about it. Today you can see our power voltage varied quite a bit. Cloudy day, ran the generator 3 or 4 times because I had some pretty heavy loads working on this container. So that's where we're at. It's coming along nicely. So any questions, leave them in the comments below. Other than that, leave a thumbs up and hit the subscribe button if you haven't already. Thank you guys for watching. Oh, and by the way, there's 5 batteries down there covered in tools. Whoops. See you guys later. Bye-bye.